All right, this is Geometry Section 1-3, Part 2. We just finished this problem, Example 4, to find midpoint of a coordinate plane, and now we're going to go on to Example 5. We've got two more examples, and Example 5 is the first of those. So here's what we're doing. We're going to find the coordinates of an endpoint. So this is a little bit different from last time. Find the coordinates of J if K, being at -1, 2, is the midpoint of JL, where L has the coordinates 3, -5. Let's go ahead and check out a picture of this. So here's our situation graphed a little bit. We've got L down here, K up here, which is the midpoint, and I guess J would be somewhere back here. And so using the actual coordinate pairs would be the best way to do it. What do I mean? Well, let's use our midpoint formula. So here's the midpoint formula for the coordinate plane, and we know that the midpoint that we're looking for, well, the midpoint that we have is K. K is the midpoint, so we know that we've got -1, 2 as the midpoint, and this other point here, let's call it J. Let's call this x sub 1, y sub 1, because that's what we need to figure out, the coordinate values of J. So if we plug that into this formula, we know we're supposed to take both of the x terms, so x sub 1, x sub 1, x sub 2, so that's x plus 1 plus 3 over 2. Are you with me? And then the y terms, that's y sub 1 plus -5 over 2. Got me? And then we know that this should give me my answer. So what I end up with is two equations. Let me go back really quickly and tell you what we did, just in case you missed it. So we know the midpoint formula gives us this. We know that K is the midpoint. So we know the midpoint formula would yield -1, 2 if we applied it to the two endpoints. So what we need to do is give give J rather, an artificial x sub 1, y sub 1, or a generic value. And then now we're going to apply the midpoint formula to that. So x sub 1 plus 3 over 2 is going to give me this value, -1. And y sub 1 plus -5, right, divided by 2 is going to give me 2. This gives me two equations. Let's solve those. So the two equations that I get would be written here, and I tried to use a little bit of color coding to help us follow through. So now if I have to solve this, what I'm going to do is try to isolate x sub 1, and I do that by first multiplying both sides by 2. When I do that, I get -2 is equal to x sub 1 plus 3. And I'm going to follow through with a simple maneuver where I'm going to do the opposite, subtracting 3 from both sides, or adding -3, and I get that x sub 1 is equal to -5. Kind of makes sense that I'd be back here at -5 on the x-axis. Let's check out what we get for our y value. So the next thing I'm going to do is solve for y by multiplying both sides by 2, which gets this 2 out of the denominator. Then I get 4 is equal to y sub 1 plus -5. If I'm going to get rid of this -5, I've got to do the opposite, which is to add a +5. Adding a +5 is going to show me that y sub 1 is equal to a +9. So now I've got my ordered pair for J. I keep calling it L. I don't know why. I've got my ordered pair for J. Thank you for being patient with me. -5, 9. Let's take a look at the last example. Here in example 6, we're going to use some algebra to find some measurements. And so what we're given here is that we've got a segment PQ where we've got a segment PR where Q is the midpoint. So find the length of PQ if Q is the midpoint of this segment. Remember the definition of midpoint? Midpoint is a point between two endpoints such that we split the segment into two equivalent segments rather, that are attached to that midpoint. So what that tells me is that PQ is congruent to QR. If that's the case, then I can simply write that 9y minus 2 is equal to 14 plus 5y. And this is indeed an algebraic problem that I'm sure you can solve. I like to gather my y terms on one side, or my variable terms on one side, and my constants on the other. And so if I want my y terms here, this guy, -2, has to move, and to move the -2, I do the opposite. So I'm left with 9y is equal to 16 plus 5y. Finally, remembering that I only want constants on this side, 5y has to go, and it needs to be moved over to the y terms. So I'm going to do the opposite. I'm going to subtract 5y, or add a -5y. When I do that, I'm left with 4y is equal to 16, and I'm sure you're excited because I am. This comes out nicely, no fractions, everything feels good. Y is equal to 4. So that's my answer, right? Not exactly. I need to go back and take a look and make sure that I'm answering the question that's asked. And the question that they asked me is, find PQ. PQ is given as this expression, 9y minus 2. So if I want to find PQ, I need to substitute 4 in for y. So PQ is equal to 9 times 4, let's put a 4 here, minus 2. 9 times 4 is 36, minus 2 is going to give me 34. So the length of PQ is 34. All right, guys, I think we've done a pretty good job today. I know two-part videos are no fun, but I'm glad you were patient with me through both of them. What I'm going to ask you to do is take the time to work on the assignment assigned now for this section. Let me know if you have any trouble, and I look forward to talking to you soon. Bye-bye.